Welcome to another Explainer. Today we're exploring a truly bizarre situation unfolding right now in one of the most rugged, biodiverse regions on Earth. I want you to imagine a dense, lush, mountainous rainforest in the high Himalayas. It's the absolute peak of the summer monsoon season, so naturally, you'd expect relentless, heavy downpours, right? Well, what if the official meteorological record stated that for nearly 50 days, not a single drop of rain fell in this entire district? Today we are unraveling the monsoon mystery of Arunachal Pradesh's Dibang Valley and looking at why a single missing piece of data is exposing a massive, terrifying vulnerability in our disaster risk management.
Okay, let's dive into this. If you check the India Meteorological Department website for the period between June 1st and July 19th, 2026, the recorded rainfall for Dibang Valley is exactly 0 millimeters. 0. And remember, this is right during the most active phase of the southwest monsoon. Under normal conditions, this border district receives over 630 millimeters of rain during this exact same time frame. To put this extreme contrast into perspective, out of all 741 districts in India tracked by the IMD, Dibang Valley was the absolute only one displaying this specific NR, or no rain status. It immediately raised massive red flags for climate watchers and agricultural experts alike.
So naturally, we have to ask, did the rain actually just stop? Are we looking at an unprecedented, catastrophic climate event where an entire rainforest simply dried up during the monsoon? No way. Local agricultural officials in the district quickly went on the record to clear the air. They confirmed that while rainfall might be a bit lower than usual, it actually is raining in Dibang Valley. The rain hasn't stopped. The data has.
And that brings us to the culprit behind the mystery. The head of the State Meteorological Center in Itanagar, Dr. A. Sandeep, confirmed that the sprawling, highly sensitive border district currently relies on just one automatic weather station. Just one. And right now, it's simply broken due to technical issues. The rainfall measurements just aren't available, which results in a big fat zero being broadcasted to the rest of the world.
So the crucial point is this. A malfunctioning weather station in a remote area isn't just some quirky clerical error. It creates a massive, highly dangerous blind spot. In a Himalayan district that's already incredibly prone to extreme disaster risks, missing weather data means agricultural cycles are disrupted because farmers don't get accurate advisories. It means disaster preparedness teams are essentially flying blind. It delays critical road maintenance in landslide-prone zones. It compromises the operational planning of massive hydro projects, and worst of all, it completely disables early warning systems that protect vulnerable communities from extreme weather events. We're talking about a literal life or death data gap.
So, to break this all down, in today's Explainer, we'll be covering 4 key areas: the geography of extreme risk, floods, landslides, and dams, the erratic climate shift, and finally, why monitoring matters now.
Part 1. Geography of extreme risk. The Himalayan frontline.
And this brilliantly illustrates exactly what we're dealing with geographically. Dibang Valley is tucked away in the upper right of Arunachal Pradesh, completely dominated by alpine and temperate zones. This is incredibly rugged, mountainous terrain. It's defined by dense forests, highly complex river systems, and very steep slopes. On top of that, it shares highly sensitive borders with Tibet. Because of this extremely challenging terrain and its overall remoteness, the ground here is highly susceptible to geological instability. You can instantly see why having accurate, real-time weather monitoring here isn't just a nice-to-have luxury. It's an absolute geographical necessity for survival.
Part 2. Floods, landslides, and dams. A precarious balance.
To really grasp the incredible stakes on the ground, we have to talk about the massive infrastructure dominating the Dibang Basin. The river system here is immense, and its steep gradient has naturally made it a major focal point for hydropower. The absolute centerpiece of this is the proposed Dibang Multipurpose Project, a colossal 3,000-megawatt dam that, if completed, would be one of the largest in India and among the tallest gravity dams in the entire world.
Now, to understand the stakes of a data blackout here, we have to quickly look at the history. As of 2016, there were actually 18 different hydro projects proposed across the Dibang Basin. The foundation for that massive 3,000-megawatt megadam was actually laid way back in 2008. Now, it's very important to note that this has faced significant opposition from the Adi, Idu, and Assamese communities living downstream who have expressed deep, ongoing concerns about the ecological and social impacts. However, in 2019, the project was formally renewed at the highest levels of government, backed heavily by its massive electricity generation potential and its intended role as a major flood control measure. But look, regardless of where you stand on the debate over megadams, the reality remains exactly the same.
Operating or constructing infrastructure of this magnitude requires absolutely flawless, real-time hydrological and meteorological data to prevent catastrophic downstream flooding.
Because the danger of flooding here isn't theoretical, it is immediate. Just look at this devastating 3-day timeline from mid-July 2026, the exact same period the Dibang station was reporting zero rain. On July 18th, workers in lower Dibang Valley were stranded by rapidly rising waters, completely halting rescue operations due to strong currents. By July 19th, fresh floods had damaged 192 roads and over 30 bridges across Arunachal Pradesh. And the very next day, on July 20th, in the neighboring state of Nagaland, an extreme rain event of 137 millimeters triggered massive landslides that tragically left 9 people dead. This is the very real, very tragic reality of extreme weather striking the unmonitored Himalayan slopes. Without early warning data, communities and workers are left completely exposed.
Part 3. The erratic climate shift, droughts, and deluges. If we zoom out to the macro climate picture for a second, a terrifying paradox emerges. At the exact same time the IMD is issuing severe red alerts for extreme rainfall, flash floods, and landslides in the Himalayan states, we are seeing staggering, almost unbelievable drought numbers. According to the India Drought Monitor, in July 2026, 98% of Manipur was under drought. Jharkhand was at 78%, and Arunachal Pradesh, the very state dealing with these devastating floods we just talked about, had 70% of its area officially classified under drought conditions. So how on earth can a state be drowning and parched at the exact same time?
Well, it's because the fundamental nature of the monsoon itself has changed due to global warming. The old monsoon that people were used to was characterized by predictable, steady seasonal rains that farmers could rely on. But climate change has ushered in the new monsoon, and it is incredibly erratic. We now see these extended, crop-killing dry spells that are suddenly punctuated by intense, highly concentrated, violent rainfall events. This means total uncertainty across the board. A region can suffer a massive rainfall deficit for weeks on end and then boom, receive an entire month's worth of rain in just 6 hours. And when that happens, you get immediate flash flooding over dry, hardened earth that simply cannot absorb the water fast enough.
Part 4. Why monitoring matters now, surviving the shift.
Which brings us right back to that broken weather station we started with. Because the climate is shifting so rapidly, historical data is no longer a reliable map for the future. The critical gap today isn't just basic weather forecasting. It's the urgent, critical need for real-time adaptive decision support systems. Farmers, dam operators, and disaster relief teams need to know exactly what is happening in their specific microclimate right now, in real time, so they can translate that information into life-saving actions. When we rely on a single malfunctioning piece of infrastructure in a highly volatile Himalayan district like Dibang Valley, we aren't just losing a few data points. We are losing our primary defense mechanism against an entirely new climate.
A broken weather station broadcasting 0 millimeters during the absolute peak of the monsoon is a glaring, dangerous symbol of a monitoring network that is desperately struggling to keep up. It leaves us with a critical, urgent thought to end on today. As our climate becomes more violent and significantly less predictable, our technology and our tracking infrastructure absolutely must be impenetrable. If we can't even measure the rain falling today, how can we possibly prepare to survive the storms of tomorrow? Thanks for joining me on this explainer. Keep asking questions, and I'll see you next time.